Good morning, good morning, good morning. Let's open up our slideshow for today. Welcome, Ricardo and Tiffany. I just let someone in that I just totally forgot who it was. Melissa. Very good, Mateo. Good morning, my friends. Joseph Gibson. Okay, so wonderful. Thank you guys for making it to class today. Kind of an important day, kind of a fun day. Actually, I mean, like, it's fun for me. Oh my God, I always say fun, but like, fun is relative. While we're waiting, if you wouldn't mind opening up the slideshow for today, that would be pretty cool. We are missing quite a few people this morning. Kind of a bummer, but that's okay. We will get it figured out. I think that I'm getting an oil delivery. Give me 1 second. Let me just check to make sure I'm bringing it. Okay, good. Okay, yes. Getting an oil delivery. That's what that noise was. Okay, Olivia is here and Rashem is here, and we're going to get started. So let me open up. Let me start to share my screen, and we will take a look at our assignment for today. Sam L is at a doctor's appointment. Yes, he did send me an email on that. Thank you for the reminder. I'm going to put a little box around his name so that I don't forget. I should have done that. Thank you, Tiffany. You are the best. Yes, the deep voice was necessary. Here we go. Once again with the deep. I don't know what's going on with that. So let's take a look at this activity for today. Let me just pull up my chit chat. Right over there. And my chitter chatter is going to be pulled up as well. And here we go. Perfect. Our activity for today, we are looking at a goal of making sense of multiple ways of solving an equation. Okay, so we have an equation here. The first activity we're doing is called different equations, question mark. And we are looking at this equation right here. Okay, and our job right now is to take this equation here and figure out which one of these equations has the same solution as this equation right here. So if we do some moves to this equation here, which one of these two will have the same solution? So what I want you guys to do is I want you to take 1.5 minutes right now to decide which of these two equations here, when I do some work to it, will have the same solution. Okay? You're going to take 1 in a minute, 1.5 right now. And my suggestion is to do what I did, to copy and paste this in here, and we can do some work with it. Yes, Tiffany, go ahead. Lando. Oh, seems maybe he got kicked out or something.
My internet cut out.
Oh, yeah, no problem.
For everyone in the house.
Oh, perfect. I mean, it's not a big deal. We're going to take another 20 seconds. Actually, we're going to take another 15 seconds. Okay. 3. Perfect. Let's come back together. Okay, so my question, first of all, if we look at this second equation down here, okay, what is different between this first equation here and this second equation down here? Control copy.
The one in the box has 4x, 2 minus 4x, and the one on the side has 2 minus 5x.
Good. So we have, so our x is changed on the right side. Good. And on the left side, it looks like we actually got rid of an x as well, right? Do we see that, guys? We noticed that. So we got an x out of the left side, and now my right side has one more x to it. So if I want to get rid of an x, how do I do that if I'm talking about an equation like this? How do you move something from, how do you get rid of something? By doing the opposite, right? We undo that by undoing it by doing the opposite. Very good. And the way that we do the opposite with this guy here is because this is a positive, because we want to move this to the other side, we're going to either add or subtract it. This is a positive x because it doesn't have a sign, so that means it's positive. So the way to move this guy over to the other side would be by subtracting x from each side, okay? So if I subtract an x on the left side here, and I subtract, I would have to do the same thing on the right side. I would have to subtract an x. Okay, so what is, ooh, this one's a tricky one. My question, I have a negative 4x, and I have to subtract an x from it. What is that? How many x's is that going to get me now? Because we're subtracting like two negatives, it's going to get to be a negative 4 minus 1.
-3.
Close. If it was a positive 1, then it would be a negative 3. But because they're both negative numbers, we add them together and make it negative. So it's going to be a negative 5x. Oh my goodness. So my question to you, so I have a negative 5x, and we didn't do anything with this 2, and these cancel out. On the left side, I have a negative 3. Is that equivalent? Are those the same equation? Nice job, Destiny. Yes, exactly. They're the same. But if we go from this first one, this original one, the red one, to this now black one down here, the move that we have to do to get there is subtracting x from each side. So this guy is going to be equivalence. Oh my gosh, guys, nice job there. Perfect, perfect. So I know that was a little bit tricky. I know that maybe we didn't really follow too much of that, but we're listening, and that's the best part, okay? Because we're going to get better with this. We're going to do more work with this. So don't feel stressed out if you didn't understand it this first time today, okay? So because today is going to be, our actual activity is kind of fun. In my humble opinion, I think it's kind of fun. So what I want you to do before I have you do anything, I want you to look at your slides down here. And the one that's in slide number 9 position, I want you to take it and I want you to move it up to, now it's in slide 7 position. Okay, so let me do that again. You have a slide that has parentheses on it. I want you to grab that slide and I want you to pull it up so that now it's slide number 7. Okay. Does everyone see how we did that? Okay, what I also am going to need from you guys is everybody's going to need a piece of paper today because we're going to be doing some work out on paper. So if you don't have paper, you need to go to a place and get yourself some and a pencil
Okay, I'll be
or
right
a
back.
pen. Perfect. Thanks, Landon. Okay. if you're still here, if you have paper for yourself, what I want you to do is down at the bottom, there is a link. It says Solving Equations Flowchart. I want you to click on that link and open up that PowerPoint. Okay, now we're going to have 2 PowerPoints open. Okay. I see a lot of friends up. I see 2 friends that are already in it. That's pretty cool. For now, you can just leave this open as a separate tab, and I'm going to go back to the slideshow for today. Okay. So if you have paper with you, I want you to write down this equation on paper. Okay. So don't write it too big because we're going to need some space to do some steps out. Okay. So let me know if you are if you're back at your computer. Let me know in the chat, like back or here. Perfect. Landon's here. Edgar's here. Jocelyn's here. Tiffany's here. Sam B is here. Melissa's here. Very cool. Very good. Sam B is here. Muka's here. Melissa's here. Olivia is here. Perfect. Perfect. Rasham is here. I can see him. Okay. So what I need from you, if you had run off to get yourself some paper, what I need from you is at the bottom of this slide, there is a link. It says Solving Equations Flowchart. I want you to open up that PowerPoint. Okay. And it's going to look like this. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 10 people in here. Very cool. I have 21 people in this meet, so I need a few more people to get to this flow chart. This flow chart is going to be your saving grace this unit. I'm telling you right now. It's going to be your saving grace this unit. This is going to be probably the most used slideshow this year so far. You're going to use this every day, multiple times a day. Okay, so I have 13 people in. Perfect. So now let me show you what you need to do. On a piece of paper, on that piece of paper that you just got, I need you to write down the equation you have here. When you look at my screen, is it backwards? Is the writing backwards or no? No, okay, good. Thank you, Rasham. Good, so I have my paper here and I wrote my whole equation on the paper. This paper is going to be important because we're going to be taking pictures of this work moving forward, okay? So you have this, maybe you have a notebook for yourself, but you're writing down your work somewhere to solve it. Because I don't want to have to make you type it out in this box because it's tedious if you have to type it. So we are going to solve this equation for x. So we are going to solve this to get the x's by itself. We're going to get an x is equal to some number. Now, let me show you how we're going to get there. So we are going to use this flow chart to answer some questions, to do some math, to get our answer. So what you need to do, if you look at the first slide here, it says to use this, be sure to hit the present button to get started. So up at the top, I want every single person to hit the present button, or well, actually I'm doing it on mine, so you don't have to, but you hit the present button to get it started. Then you move forward one slide and it's going to ask you a question. This only works though if you're in present mode because it's going to link you to different slides in this slideshow. Okay. So the first question, does your equation have variables, letters, on both sides? And I gave you some examples of what they might look like. We have an X on the left side, X on the right side, or does our equation only have an X on one side? Let me know in the chat. Is it on one side, 1, or 2? Do we have X's on one side or 2? 1 or 2? Let's look back at our equation. Okay, If we look at our equation here, we have an x here on my left. In here, I have an x here on my right. So we have x's on both sides. So from there, if you have x's on both sides, you click this yes button and it takes you to another slide. Do you have a proportion? Meaning a fraction equal to a fraction. I gave you an example here. Does our equation have a fraction on both sides, yes or no? I had two friends. Nice job, Landon. Nice job, Joe. Let me know in the chat. Does our equation here have a fraction on both sides of the equation? Very good, Destiny. Very good, Tiffany. That is a no. So I'm going to click the no button for myself. Boom. Okay. Is there anything to distribute? Are there parentheses? Let's look. Are there parentheses for us? Very good. Yes, there are. If you look at your left side on your piece of paper, there are parentheses that I have to distribute here. So I'm going to hit yes, and it's going to tell me to do something now. Okay, it says we need to distribute. Oh, this is hard. Distributing, meaning that we're doing multiplication, this number outside times both of the pieces inside. My question to you, if I'm looking at our example here, I just have a negative sign outside there, right? I have a negative sign outside of my parentheses here. What number is represented what number does that mean? Negative. If there's no number there, it means a negative.
10.
Not a 10, it's going to be a -1. So you can write it as, let me just do a different color so you can see it. So you can rewrite this as a -1 on the outside of your parentheses. Do you see me in my picture here? Very good, Tiffany. So now we need to distribute. That means I need to multiply this -1 that's on the outside times both of the pieces that are inside. Okay, so that means I need to multiply -1 times 3x. What's -1 times 3x going to get me? Very good, Tiffany. Nice. But what kind of 3 though? Because a -1 times a -1 times a 3x is going to get me a -3x. Nice job, Destiny and Tiffany there. Very good. We have a -3x, and now we need to distribute my -1 times my +12. What's -1 times +12? Very good, Tiffany. Nice job, Samby. What's it going to get me? -1 times 12. Or times -12. That's a -12. I'm sorry about that. Mr. Me, you are a stinker. I read it wrong. I'm sorry about that. So when we do the -1 times a -12, that gets me a +12, because any number times 1 is that same number. And because it's a negative times a negative, it gets me a positive. Very good, Sam B. So this is what you should have on your paper now. We have this -3x plus 12 is equal to the other side. You bring the other side down, 9x minus 4. Okay? Let me show you what that looks like. This is what you should be having right now to be done with. Like we're going to move forward from here. We haven't gotten our x by itself yet. So once you distribute, you hit the next button. It's going to take you to the next question it's going to ask you. Okay? Are there, let's see, let me read this. Okay. Are there any fractions that have a constant and variable in the numerator? That means that it has not just an x or a 2x in the numerator, it has an x plus or minus something. Do we have any fractions here? Nope, we're here. No, if we look at this line right here, this next step here, we don't have any fractions. So we don't have any fractions that have constants or variables. So we're gonna hit the no button because there's no fractions there. Okay. Now it says we need to combine like terms. If we look at this equation here, are there any, if we're looking at the left side, right here, are there any x's that we need to combine here? That's okay, Samby. What do we think? Yes, we have the negative 3x and we have the 9x. But the thing is that the equal sign is in between them, so we can't just combine them. We're going to have to do something else with them afterwards. So do we have on the same side of the equal sign? Basically what I'm saying is on either side of the equal sign, do we have any terms that we can combine? So in each of these little pieces here, on the left side, are there any x's that we can combine here? No, very good. On the right side of the equal sign, are there any x's that we can combine here? No, very good. So when it says combine like terms, you're looking at each side individually, right? So you're saying on my left side of the equal sign, are there any x's or constants that I can combine? Nope. If I'm looking at the right side, are there any x's and constants that I can combine? No, there isn't. Okay, nice job. So we don't have to combine anything, so we hit the next button. Now, here comes this is where we're gonna really work hard here. If there is x's on both sides, which we said there is, we need to find the smaller x and bring it to the other side. So if I'm looking at what's left on my paper here, which of these x's is smaller, this negative 3x or this 9x? Which is smaller, this negative 3x or this 9x?
The negative 3x.
Very good. Nice job, Joe. Nice job, Rashem. Nice job, Tiffany. Yes, the negative 3x is smaller. Okay, and I need to bring that to the other side using my inverse operation. So if this is a negative 3x and I want to bring it over to the other side, what's the opposite of negative 3x? What's the opposite of minusing a 3x? Very good, Rashem. Very good. The opposite is a positive 3x or a plus 3x. So on each side, if you look at how I did this here, we would write it as a plus 3x underneath it because we're adding 3x. And then if we did it on the left side, we have to do what to the right side?
Add the same amount.
Very good, Landon. Yes, yes, Gio. We have to do the same thing. So if I add my 3x on the left side here, I have to add 3x on the right side here. Let me show you what that's going to look like. Okay, so on your paper, you have this guy here. We have plus 3x plus 3x. When we add 3x on this side, it cancels them out. My 3x's on the left side are gone. I have to add my 9x and 3x. What is a 9x and a 3x combined to? If I have 9 and I add 3 more x's. Very good, Tiffany. Very good, Sam B. Go ahead, Joe.
12x.
Very good. It combines to a positive 12x because 9 plus 3 is equal to 12. Very good. Nice job, Tiffany and Sam B. It combines to a 12x. So this is what I'm doing here. I'm bringing down my equal sign. When I cancel this out, what am I left with on the left side now that I need to bring down? So these 3 x's cancel out. On the left side, I'm left with, very good, just that 12. That 12 is equal to 12x. And then I have to bring down that constant. So it's 12x what? Very good, Tiffany. So we have, but we're not going to do that yet, Sam B. We have to bring down that -4 first. So it's 12 is equal to 12x minus 4. We need to bring that -4 down first because we didn't do anything with it. So it brings it right back down here. So when we rewrite it and we're at the end of this step, we're going to be left with 12 is equal to 12x minus 4. Okay, so that's where we're at now. And then since we're done, we just did that, we're going to move on to the next. We're going to hit this next button down at the bottom because it's going to take us to the next piece of this. Okay, now we have our next question here. The next question is on the other side, on the side with the x. If there is a constant, a number with no letter attached, undo that constant by using the inverse operation on both sides. So I'm looking at my side with my x. Is there a constant on that right side? A number without a letter attached. Very good. Yes, there is. If you look at it, we have this -4. And so it says we need to move this over to the other side by using the inverse operations. So if this is a -4, what am I going to do to both sides to get rid of it?
-4.
It's already minus though.
Add
We need
4.
to
Add 4.
Very good. We're going to add 4 because it says -4. So to cancel it out, we need to add 4 to what? To both sides. Okay. So I have my add 4. On the right side, they cancel out because a +4 and a -4 equals 0. So that means they cancel out. What is 12 plus 4 get me on the left?
16.
16. And it's just a 16, not a 16x. Very good, Tiffany. Good catch there, Matthias. Awesome job, Matthias. It gets me 16 is equal to what's left on the right side.
12x.
Yes, Landon. Very good. It's 12x. We can't lose that x. Good. So we're there. Ours looks like this one here. We have a constant and a some number x on the other side. Let's hit the next button and see what happens. Now it says undo multiplication or division done to the x by doing the opposite operation on both sides. So my question, what we have here, what we have left in my picture here, does it look like the one on the left with this multiplication or the one on the right?
The one on the left.
Yep, so look at my picture of my screen. What we have left there, does it look like the one on the left or the one on the right?
The one on the left.
Very Very good, Landon. Very good, Olivia. Very good, Tiffany. It looks like the one on the left. So to cancel out that 2 that's attached to our, or that 12 that's attached to our x, we're going to have to do what operation? So this 12 is attached to this 2 through multiplication. How do I undo that 12 there? Very good, Olivia. Very good, very good. We're going to have to undo it through division. If we have a number attached to our x through multiplication, we undo that with division. So we're going to divide by 12 on each side. And we're going to get a final, very good, Sam B, very good. We're going to get a final answer of, because these 12s cancel out on this x. Okay, and we're going to say 16/12 is equal to x. And I would say leave it as a fraction. X is equal to 16 divided by 12. Okay, so your paper should look like mine. Okay, you should have this problem worked out on your paper. Okay, so I'm going to close out of it because if you hit the next button, congratulations, you solved for x. Woo-hoo! Okay, so let me show you how we're going to insert pictures because you're going to have to do this afternoon. So let me show you. Okay, so if you're in the slide, you're doing your work on your piece of paper, which needs to happen because that's where the credit for today is coming in. We're going to insert we're going to take a picture of our work by hitting the insert button up at the top. Hit the insert button. You have your drop down. You're going to go to image and you're going to go to camera. Okay. It's not going to allow me to use this camera, so just give me 1 second.
Miss, we can't hear you.
What about now? Can you hear me now?
Yeah, we can hear you.
Perfect. Thank you, Tiffany. So you are going to insert a picture of your work. Sorry, let me just find out where I put my camera. Hi there. Once we're in school, this is going to go a little bit better, but for today, this is what we're starting with. So if you couldn't find good paper, we have to sort of, for the afternoon work, you're going to have to find some paper somewhere. So, or if not, you can type it into the slides, but I'll show you how to do that in school tomorrow. So what you're going to,
inserted it.
what was that?
I just took the picture and inserted it.
Perfect. So you take you go insert, you go image from camera. Mine's not letting me insert it because I am using my camera to talk to you guys. So then from there, I'm going to actually, wait, what if I do this? And then what if I cancel and then I try it again? No, okay, can't because I'm still using this. So you're going to hold it up to the camera like this, take a picture and insert it. I go through the steps again in the afternoon work video. So if you don't know how to insert, yes, you can do it for homework, Edgar, not a big deal. Yes, you can do a picture through your phone as well. If you take a picture on your phone and you upload it to the Google Drive and insert it that way, you can do it that way as well. And I will walk you through that step on Monday, one day in class, okay? For friends that don't know how to do that. So you need to take a picture of your work somehow. Take a picture of your work, whether it's on your phone and insert it or using your camera and inserting it that way. Does anyone have? Yes, so we have science. So you guys can head out. There is a video this afternoon. Listen, if you send me the code word for this afternoon, it's going in as a mini quiz grid because the video is a little bit long. So make sure it gets done. Reach out with questions. I know that it's a little bit long, but I go through 2 examples using that. Trying your best. Like I said, if you do the code word, it's going to be a quiz. So I will see you guys next Tuesday. If you have other questions, let me know in the chat. You guys can head out to science though.
Good day.
Bye.
Bye guys. I'll see you on Tuesday. Hector, are you there, dude? Hector.